Okay, so this is part 3 of the Kyosho Ultima RT6 build series. I have part of the front end done here, basically the bulkhead, the steering rack, and the assembly for the front arms. So this does go together in a very interesting way. Let's see, what do I want to say? Well, first off, I just took a couple of the screw bags and emptied them out because, you know, when Kyosho tell you to use a particular screw, you don't really know what screw bag it is, because even if they give you the parts bag number, like parts bag 1 or parts bag 2 or 3, there are actually, you know, a couple of different screw bags in some of these bags. So just, you know, pour them all out in here and measure them out, and you'll be okay. Going here, right, the part 2 video talked about how they actually incorrectly labeled one of the bags you'd need to get these little washers here, or these collars. But otherwise, this part goes together okay. There's nothing, you know, too crazy about it. Make sure to use thread lock in any part where you have a screw or a ball stud screwing into metal. So all of this steering rack here is metal. This is aluminum, this is aluminum, this is aluminum. So this ball stud that eventually attaches to the steering servo, these two ball studs here on the left and right, make sure to use thread lock on those. And then these screws that screw through the washers here, okay, up into these two arms, use thread lock there. Okay, the manual doesn't tell you to use thread lock, but they do remind you to use grease on these little bushings here that go on the cross member for the steering rack. But again, use thread lock on all the ball studs and screw parts, okay? For the front here, on the front arms, these arms are actually kind of interesting. So they come with these little attachments that you screw onto the arms, and then you mount the bottom of the shocks onto either of these 3 holes here. And what's neat is that the way they slot into the arms, there's actually 2 sets of holes that they slot in. So you could slot this in towards the right or towards the left. So technically you have 6 options for where you want the bottom of the shock to be located, okay? And then if you really want to get a little funky, you could take this thing and flip it around, and in which case, instead of the holes going higher as you go out, they would go higher as you go in. So if you want to run, say, the shock with the bottom of the shock towards the inside and you wanted more droop, you could just take this and flip it around so that this end is on this side, and you can get that kind of behavior if you really wanted it. So there's actually quite a lot of options here for how you can mount the bottom part of the front shocks. So that's kind of interesting. This little, okay, so then you mount the hinge pins into this basically kick-up unit here. This is kind of similar to what you would have on a B5 kind of build. Depending on which way you orient it, you'll get either 25 or 30 degrees of kick-up on the front arms. And then when you mount them in, you have these slotted hinge pins that mount through the arms and through this little brace, and then you tighten it down with a set screw, okay? And then the ends of these are braced with a front hinge pin brace, this metal part right here, okay? Now, this front hinge pin brace does not screw on to any part, okay? This just slides right in, and then it is held on by the front bumper, okay? The front bumper is just kind of a normal, if not smallish, front bumper. So if the nose of this bumper starts to wear out for any reason, and then it comes off, then there will be nothing holding on this front hinge pin brace, okay? And this can end up popping off. So make sure to pay close attention to the condition of your front bumper if you don't want to end up losing this front hinge pin brace here. All right. Let's see, what else do we have here that's notable? Oh, right, this plate. So what's kind of interesting is if you look at, say, again, I'm referencing the B5 series because that's what I'm familiar with. Normally you would take this whole assembly here and you would mount it onto the top of the chassis facing down, and then the screws would come in from the bottom. Here, this brace mounts onto the bottom of the chassis, and then the bulkhead mounts on the top, and they sandwich the chassis, and then you screw everything in. So that's interesting, I suppose. And on top of that, there's this little plate you put in here between the chassis and this bottom assembly here, and they come in 2 thicknesses. So you get this parch tree. On this side is this little kick-up brace here, and then here there's 1 plate, and then there's another one on this part of the tree. And this plate here has a 0.5 millimeter thickness, and the one I mounted has a 1 millimeter thickness. And the manual does not even give you a recommendation as to which one to use. It just says, it is used by setting, so not particularly good English translation there. But basically they're trying to say, depending on what setup you want, you would use either the 1 millimeter plate or the 0.5 millimeter plate. But they don't give you a baseline starting point, right? As they would with like all the ball stud settings, like for the camber gain and roll center. So you have to make a guess. If you use the thicker plate, that basically pushes the arms down, which effectively pushes the chassis up. Okay, so that will give you, maybe you would want to do that on a bumpier surface, or if you have larger jumps, so you can get a little bit more clearance for the front. Basically allows you to get a larger front ride height, or maximum front ride height if you wanted it. And then the thinner plate does the opposite, right? It'll pull the arms up and push the chassis down a little bit. I suppose in theory you can run no plate whatsoever, in which case the arms would be at their highest possible position and effectively pulling the chassis down even further, right? So I kind of took a guess and went with the 1 millimeter plate because honestly I don't know. I don't know exactly how it's going to pan out, but I do expect to run this on an outdoor track. It's going to be a little bumpier, you know, maybe the types of jumps that will be on the tracks I'm on will require more front ride height. I don't know. And really, if you're going to run something like, say, a 26 to 28 millimeter ride height, you could probably accomplish that with either of these plates or no plate whatsoever. So I'm really not sure why they even bother to put this plate in here, to be perfectly honest. But for what it's worth, I tried the 1 millimeter plate, and we will see where that gets us. So up next is mounting the servo. One thing that's kind of interesting is for a modern kit, they're giving you this kind of servo saver that you have to assemble. This is a really old school kind of a setup, right? They give you this little spring and you put it in the servo horn and it acts as a servo saver. It's old school because a lot of the really old chassis used to have something like this, like the old Tamiya chassis. Even the old Kyosho chassis had something similar. And then eventually in the 1990s, companies started integrating servo savers into the bell crank itself. In fact, even Yokomo had that going way back to the 1980s. And then people would just not run servo savers at all. They'd run a locked bell crank with no servo saver, and they would run just a straight up servo horn on the servo to get, you know, maximum steering response. So I'm not sure that this servo horn is completely required, although they do give it to you for the build. So I'm probably not going to use it. I'll just use this standard servo horn. And I may end up mounting the servo later when I do all the rest of the electronics, unless, actually, you know what? I might have to mount that soon. Yeah, because once you mount the servo, then you got to put this brace over it as part of the build. So I have to mount the servo now before I can really proceed. Otherwise, I won't be able to access this part of the chassis to mount the servo later on in the build. So I'm going to have to tear a servo out of one of my other cars that I don't use very often and throw it in here. So let's see, I'll get through that, and let's see, maybe I'll get through this bit here and make another video. Okay, so thanks for watching.